My name is Eric, and I'm a data science professional with a passion for data analytics and machine learning. For my capstone project, I wanted to take a deep dive into another passion of mine, which is baseball. In fact, baseball analytics is how I started my own personal career transition into data science. So tonight, I'm excited to share with you my project, stepping up to the plate, predicting MLB player salaries and team wins with machine learning. Yeah, I should make this full screen for you. In my previous career, I was a project coordinator working on construction projects throughout the city. I worked on many exciting projects, but I felt like I had to follow my passion, which I always had an interest for, which was baseball and sports. So if you're a sports fan or a fan of the movie Moneyball or seen it, one common issue that teams face is how they spend and allocate money when it comes to building a team. And just like any business, a Major League Baseball team operates very similarly. So the core subject in Moneyball was how smaller market teams such as the Oakland Athletics can compete with larger market teams like New York and Boston, who ultimately have a lot of freedom to spend as much more money, right? So for my capstone, I wanted to explore that a little bit further and predict the MLB player salary, pitchers and batters using historical baseball data. And secondly, I wanted to better understand what statistics contributed the most to winning when it comes down to predicting team wins. The data set for this project consisted of historical baseball statistics and advanced statistics. In 2014, Major League Baseball introduced StatCast, which allowed teams to collect more baseball data than ever before. This included detailed statistics such as how hard the ball was hit, how many revolutions per minute the ball was spinning, and many, many more other features. The key takeaway here is that the advanced statistics have far more features or variables to work with, as you can tell. So taking a glimpse at the data set that I was working with, we see some of the highest paid players in baseball. This kind of gives you a good perspective of some of the top echelon of stars in the game as of 2021, as some of the top players are making in the tens of millions of dollars. And I considered most of these players as outliers. However, since 2000, I noticed that the average batter and pitcher make far less than the outlier group that we just saw previously. Batters are more recently making about $5 million on average, compared to the pitcher making about $1 million less. And as I mentioned, Major League Baseball has incorporated data analytics more than ever. When taking a look at team salaries and wins during the 2021 season, we can discern some noticeable observations based on this chart that I made here. We especially see data analytics used heavily for teams like the Tampa Bay Rays, who are on the far right there with 100 wins, and the Milwaukee Brewers directly adjacent to that with 95 wins. And these are two example teams that have a smaller relative payroll than some of the bigger market teams like the LA Dodgers or the New York Yankees that you see all the way in the far left there. In terms of results for my predictive models, I was able to achieve a margin of error of under $2 million using basic data alone. For advanced data, the margin of error was roughly about $2.8 million and $2.4 million for batters and pitchers, respectively. One thing to note is that the reason for the disparity of the margin of error is due to the different size of the data sets that were used. When predicting team wins per season, this was a fairly simple linear regression model where I was able to achieve a margin of error of 1 win using advanced team data, thus indicating that there's a strong linear relationship between features and wins. So quickly, I just want to show, if I can get to it underneath here, this application that I made, basically using Streamlit, which is a type of technology that allowed me to build this web application. Essentially, I developed a pair of locally run applications that take in basically user input and can provide a salary prediction for pitchers and batters. So, for example, you essentially load in custom inputs here. So this first input here is $750,000, which is the average salary difference across a player's career. This gives you kind of a little summary of how that was feature engineered. And ultimately, you can just shift around some of these values for batters. So you can do whatever you want. You can make whatever player you'd like to make for this previous season and essentially just hit submit. And it gives you a predicted player salary of $3.8 million. Hopefully you can afford that if you're building your team. So another thing I wanted to take a look at when I uploaded and was working on this project was how does that compare to this season's statistics and how much money that players this year might be making as of August 24th is when I loaded this data set. So if you're familiar with the game of baseball, one player that's doing exceptionally well this year is Aaron Judge. He plays for the New York Yankees. He's recently making $19 million this year. My model is predicting he makes 21 million as of August 24th. One would argue that's still underpaid, but essentially you could kind of go through this list and kind of tell based on the season statistics alone if a player is overvalued or undervalued. All right. Oh, let me go back. Okay. So in terms of technologies that I was using, the main language was Python and incorporated the scikit-learn library to apply those machine learning techniques for this project. Visualizations were developed using Tableau software, and the web application was deployed through Streamlit, as I mentioned. And all the data was sourced using the PyBaseball library and sourced ultimately from Fangraphs. So there were a few notable challenges I encountered when working on this project. One being narrowing down as many features to the most important features that gives me the best predictions. As I discussed, there was many features to work with. Simpler models are generally preferred since they are easier to interpret and understand. This is where domain knowledge about baseball especially helped me the most in identifying those important features. Additionally, reducing the margin of error for predictions was especially difficult since there are those superstar players who are making well above the average salary. So there are other factors that are not necessarily explained in baseball statistics alone that can account for a player's salary, such as basic economic demand for a player in a particular offseason. And finally, thank you. Below are my contact information and project repository. So I hope you were able to come away a little bit about some knowledge of machine learning and the sport of baseball.
Awesome job, Eric. Thank you so, so much. Again, everyone, please remember to take a screenshot of all of Eric's contact information so you can reach out at another point, or go ahead and quickly jot it down right now. This was really cool. I'm going to come back in my next life as a MLB player, because I would like to be making that Aaron Judge money. Thank you very much. Okay. So we have one question. What's the source of your data set?
Yeah, so if anybody if you're a fan of the sport itself, you can generally look up or are aware of baseball statistics. They're readily available online. I got all my data from Fangraphs, and there's this concept called web scraping where you can get all that information online easily. So I used a package that was developed by others called PyBaseball, PY Baseball, and essentially it's as simple as typing in what you want, and that data will be pulled using that package. So it was really helpful in collecting all of that information, because I ultimately created a lot of models, and I didn't share with you the pitching side of the web application, which I also did. So it incorporated a lot of information that I had to do within about a 2.5 week time period.
Awesome. Yeah, I will say it surprised me that pitchers make less than batters. Was there anything else that surprised you when going through this data set?
Yeah, there was a lot of missing information for sure that I had to handle, and that's another aspect of machine learning and data science that is kind of the crux of data science, is that it's your models are only going to be as effective as your data. And so there was a lot of engineering that had to be done, a lot of cleaning. In terms of surprises, I was actually pretty surprised how well it was able to predict Aaron Judge. He is having or have had an amazing season. So my model up to the point where just before the season end was actually predicting 21 million. If you ask people in the industry, he's probably going to be making close to double of that after this year. So my model does have its limitations for sure, but it was actually able to predict pretty well on the average player. So